This is a review for your Chapter 9 quiz over the first few lessons in the book. This will be the exact same types of questions on your quiz, so if you pay attention, you should do really well on the actual quiz. For the first couple of questions, it asks you to determine whether each relation is a function. And remember that a relation is just a set of ordered pairs that we have right here. And in order for it to be a function, we have a couple of different strategies, one of them being the vertical line test. So over here on the right, I have drawn a couple of graphs. And if I can draw a vertical line and it only passes through one of the points on the graph, then it is, yes, a function. Whereas if I draw a vertical line and it passes through more than one, then no, it's not a function. So that's one method. For the first two problems on the quiz, you have a set of ordered pairs. So what you're looking for is each domain having only one range. So in this case right here, 2 is going to all sorts of different ranges. And if I graph that on a coordinate plane right here, you'll notice that 2, 0, 2, 2, 2, 4, and 2, 6 all line up on a vertical line, which therefore does not pass the vertical line test. So no, it's not a function, okay? And for the explanation, you could just simply say it doesn't pass the vertical line test. So one strategy you can use is to graph those points on a coordinate plane and see if it passes the vertical line test. But we have to have a different strategy, especially for problems like number 2, where I have some of these ordered pairs that are larger x and y values. So I don't want to make that graph. So I have to just eyeball it and make sure that every single domain has one and only one range. Okay, so I can see 1 goes to 12 and there's no other 1s in the relation, and there's no other 4s, so none of the domains repeat each other. Okay, it doesn't matter if the ranges repeat. That's okay if 1 goes to 12 and 4 also goes to 12, but it's not okay if 2 goes to 0 and 2 also goes to 2. So for number 2, we would say yes. Okay, yes, it is a function. Okay, and your explanation could be because it passes the vertical line test, or you could say each domain has exactly one range. Both of those would be acceptable explanations. For numbers 3 and 4, it says to find 4 solutions for each equation and write those solutions as ordered pairs. Typically, when I am picking numbers for x, I choose 0, 1, 2, and -1. You can pick the number 100 for all I care. You can pick the number 1,500,922 as a number. But the whole point of picking 0, 1, 2, and -1 is, 1, they're easier to graph on a coordinate plane. And then number 2 is just really simple numbers to work with. So if I plug in the value 0 for x, 3 times 0 is 0. And then if I plug in the number 1 for x, 3 times 1 is 3, okay? And if I plug in the number 2 for x, 3 times 2 is 6. And so I'd write that right there. And it also says -1. -1 times 3 is -3. Okay, so if I was making a t-table, that's how it would look, but it says to write them as ordered pairs. So make sure you have your parentheses and your commas in between there. 0, comma 0 is one of them, and then 1, comma 3. It doesn't look like much like a 3, but make sure you have 4 ordered pairs and that you pick numbers that are pretty easy to work with. If you want to stretch yourself and pick different numbers, that's fine. It's just not necessary. For number 5, you are graphing an equation using the x and y intercepts. And x and y intercepts is just plugging in a 0 for x and a 0 for y, so you can see where that line crosses the x and y axis. So let me change colors here, and let's put in 0 for x. If x is 0, we have y equals -1. Okay, so one of my intercepts is 0, -1. Let me go put a dot over here, and I'll move it to 0, -1. Okay, 0, -1 is my y intercept. When x is 0, my y-intercept is -1. When y is 0, if I put 0 in for y, I get x minus 1. Well, what minus 1 equals 0? Well, that happens to be 1. 1 minus 1 is 0. And so when y is 0, my x value is 1. So my x-intercept is at 1, 0, right there. Okay, so I'm going to finish my graph by drawing a line through those 2 points, making sure to put an arrow at both ends indicating that there's infinitely many solutions. Again, I could pick the number 100 for x, okay? And if I pick the number 100 for x, what's 100 minus 1? 99. Okay, so I could plot the point 199 on my graph. It would be somewhere way over here, okay, but it would still be on this line continuum there, okay? I could also pick the number 3. What's 3 minus 1? Up here, 3 minus 1 is equal to 2. So the ordered pair 3, 2 is also a solution. And my graph isn't quite straight there, but 3, 2, let me go ahead and grab another point here. Let me get this out of the way. 3, 2 is on my line right here, okay? So no matter what value I pick for x, it's going to end up on that line, okay? It's just a matter of picking numbers that are easy to work with, like the number 0, okay? So that's how you would do number 5. When you have to identify the x and y intercepts, you would list these 2, and then next to it say which one's the x-intercept and which one's the y-intercept. Okay. For number 6 and 7, it says find the constant rate of change, and really that's just another way of finding the slope, which is the change in the y values over the change in the x values. So it doesn't matter what values you pick here for the first order pair. I'm just going to take 15 minus 8. 15 minus 8 is equal to 7, and then 5 minus 4 is 1. Okay, now this one's kind of a little bit of a easy one because it already tells you that it's a constant rate of change, so you really don't have to check any other ones. If the question says, is this a constant rate of change, you'd want to make sure that every single pair of x and y's equals 7. But in this case, it tells you that it's a constant rate of change, so I just did 1 and I have my answer. But just to double check, let's take 8 minus a -6. So 8 minus a -6 is 14, okay? And 4 minus 2 is 2. So 14 divided by 2 is also 7. One more, what's -6 take away a -20? Actually, let's do this the other way. Let's take -20 take away a -6. -20 take away a -6 is -14, okay? And -14 over 0 minus 2. Notice if I go from -20 to -6, I have to go from 0 to 2. Okay, so just make sure you're doing it in the same order. So I still get -14 over a -2, which ends up being a +7. Okay, so 2 types of questions usually revolve around these kinds of items here. Either A, it asks you for the constant rate of change, which it's doing in this quiz question, and all you have to do is find 2 y values and subtract them, and put that over the corresponding x values subtracted from each other. Okay, and that gives you the constant rate of change. Or if they said, does each table represent a constant rate of change, that's when you're going to have to make sure that every single pair of x and y values comes up with the same value, and then that's a yes or no question. But in this case, it's just what is the constant rate of change, so find the values, subtract them, and then write that in. For number 8, it's talking about a direct variation, and the direct variation equation is y equals kx. And your big giveaway is right here. There's no plus or minus after the x, and so yes, it is a direct variation right here. Y equals $1.99x. There's no plus or minus after the x, so yes, it is. Okay, now as far as your explanation goes, there's a couple of ways to determine whether or not an equation is a direct variation. One, you could say because it follows the format of y equals kx, which is the direct variation equation. Okay, or you could say it passes through the origin. It passes through 0, 0. And that's a must in order to be a direct variation. It has to pass through the origin. And if you put numbers with this situation, if you download 0 songs, it's going to cost you $0. So that's a must. It has to pass through 0, 0, and then it has to be in this format, y equals kx, which right here, technically, we could put plus 0 without changing it. It's going to pass through the origin. So either one of those explanations is acceptable. Yes, because it follows the format of the direct variation equation, y equals kx, or yes, because it passes through the origin. All right, for numbers 9 and 10, it says to find the slope. Again, we're using this y minus y over x minus x. So in this one, we have 5 minus 5 for our y's, which is 0. And then our x minus x, it really doesn't matter because 0 is in the numerator. And 0 divided by anything is 0, and that's going to be a 0 slope. Notice that if we plot these 2 points on a coordinate plane, it gives us a horizontal line, which is 0 fun for slope dude. So just keep that in mind. For number 10, we have over 3 down -6 and over 3 down -9. That goes up to the very top on deciding whether or not it's a function or not. In this case, we have 2 domains going to 2 different ranges. And if we plotted those points, it would make a vertical line, which is an undefined slope for slope dude. And if we did the actual math to prove it, we would take -9, right? -9 minus a -6. And then in the denominator, we would take our 2 x values, which is 3 minus 3. Well, 3 minus 3 is equal to 0. And a 0 in the denominator is an undefined answer or undefined slope. Finally, for number 10, it says that the total expenses for a small business owner varies directly. There's that direct variation again, which is this format, y equals kx. Always going to be in that format if it's a direct variation equation. Okay, so it says that the owner spends $680 if a consultant bills for 8 hours of work. Write an equation to determine the expense per bill. Well, it just said that we have 8 hours of work for $680. Okay, so what I have there are an x and y value that I can plug in to my equation and find out what that constant is. Okay, so if you plug in 680 for y and 8 for x, how would you find the constant? Well, you would take 680 divided by 8. Okay, so if I take 680 divided by 8, I get 85, which means that my small business owner charges $85 an hour. So the final equation for determining the amount that you have to pay for X number of hours would be y equals kx, and in this case the constant is $85.